So chapter 6 takes us the route of radicals. I kind of hinted towards that first semester when we hit a radical within the quadratic formula, and we would have to simplify that radical within the quadratic formula. For instance, simplifying something like square root of 28, where it was 4 times 7, and we could break that square root of 4 down. Okay, so that's the direction we're going in this chapter. Everything radicals. Today, we are just kind of working with, actually we're working with any type of radical today. So today we're looking at square roots, cube roots, fourth roots, fifth roots, all the different types of roots there. So we will talk about calculator usage a little bit, but more than anything, we're going to rely on our brains as well. Okay? Yes?
Is that h is 0?
Yes, it is.
Okay.
Yep, I'm getting ready to talk about that. So we start off lesson 6.1 with just some property reviews listed up there. Now, the first one that is part of a hole punch issue when I make the copies is it's supposed to say a to the 0 equals 1, indicating, as a friendly reminder, anything raised to the 0 power is always equal to 1. Okay, your calculator can help you remind you of that if you forget. Type in something to the power of 1 on your calculator, and you're going to get, type in something to the power of 0, and you're going to get 1. Okay, so some other basic reminders. Division. When you divide and the bases are the same, a to the m divided by a to the n, remember keep the base and subtract the exponents. When you multiply and the bases are the same, a to the m times a to the n, keep the base the same and add the exponents. We're going to practice with these. So, negative exponents. I believe we talked at the end of last semester. How do you get rid of a negative exponent? You move it to the denominator. And maybe that was in my pre-calc classes that we reviewed that. I don't remember. But negative exponents are often not appropriate in a final answer. They won't want a negative exponent. So in order to get rid of a negative exponent, we move it across the fraction bar. Okay, or we say move it across the magic line there. Another one, if you have a power outside of a parenthesis, it goes with every factor inside the parentheses. So AB to the n is A to the n, B to the n. Same thing out about division. A divided by B to the n, A to the n divided by B to the n. Another thing, when you're raising a power to a power, so when you've got a power raised to another power, you multiply those powers. And power raised to a power, even when there's division, again, you multiply those powers. So a to the mn divided by b to the pn. So those are technically some rules you're supposed to already know. I don't know how well we remember them, but friendly little reminders there. So example 1, we're going to go through and just work with some of these rules. The directions are just to simplify and rewrite each expression using only positive exponents. So, as we look at example A, 5a to the third times negative 3a to the negative fourth. Thoughts on where to begin there? How do we multiply 5a to the third times negative 3a to the negative fourth? What? Gotta get you back into your math brains is what I've got to do here. How do we multiply those? I disagree with the calculator because that's not going to let me type in my A's. Even my fancy graphing calculator isn't going to let me type this in and give me an answer. Okay. Okay. So add the exponents. What do you guys notice inside here? These are both a to some power, yes? So if you think about the fact that these are both a to some power, it's a to the third times a to the negative fourth, which is going to make it a to what power? What is 3 plus negative 4? And 3 plus negative 4 is negative 1, yes? Now, what part did I ignore? The 5 and the negative 3. What do we do with 5 and negative 3? You multiply them. It's a multiplication problem. Those are just integer coefficients out front. 5 times negative 3 is negative 15. So I currently have negative 15 a to the negative first. So I have multiplied my two terms into one term. Am I done? Can I stop here? No, because the direction specifically said rewrite each expression using only positive exponents. Okay, MathXL is likely not going to allow you to leave any negative exponents in answers tonight. Okay, so how do I deal with the negative exponent? How do I get rid of a negative exponent? Abby? Put it in the denominator. Now, when we say put it in the denominator, what am I moving to the denominator in this problem? What has the negative exponent? A has the negative exponent, yes? What about that negative 15? Does it have a negative exponent? No. Negative 15 is being multiplied by a to the negative first. But negative 15 does not have a negative exponent, which means where's that negative 15 going to stay? Out front, which is going to correlate to staying on top. Okay, because if we're going a fraction bar here, a to the negative first has to move to the denominator and become a to the positive first. That negative 15 is not tied to that negative exponent. So it has no negative exponent to move it to the denominator. So negative 15 is just going to stay. So I have negative 15 over a to the first, which if I was writing this, I would write it as negative 15 over a. Just because I don't need to write a power of 1. Okay. That negative sign could also be out in front of the fraction bar. That would be equivalent. Questions? Yes? I was debating how I wanted to answer that. I mean, the key that I will say is why can't we say multiply by negative 1 and change the sign or something? And the key is it's not an equation, right? It's just an expression. So we can't do anything like multiply, add, subtract, divide because we'd be changing the value there. Okay? Okay. Let's look at B. Negative 4, x to the negative third, y to the fifth, parentheses, quantity raised to the second. Thoughts on where to begin? Okay, multiply both exponents by 2. So this exponent of 2 out front has to go with each factor in the parentheses. So it's going on y to the fifth. I agree we're going to do 5 times 2. It's going on x to the negative third. So I agree we're going to do negative 3 times 2.
So we don't have to put 5.
No, you're not actually. The exponent rule here says that when it's a power raised to a power, you multiply those powers. We're not going to do 5 squared. Huh? Right. Mm-hmm. Yep. Now, okay, and so that's the other thing is I hadn't really finished here before I was going to write my next step. What about that negative 4? What's the power on negative 4? It's a 1, right? So that negative 4 is also going to have to be raised to the power of 2. Now I'm going to kind of write a beginning step here. Some of you have probably already advanced the next step, which is fine. But the idea is we're going to have to do negative 4 to the second, x to the negative third raised to the second, and y to the fifth raised to the second. Okay, so that's kind of what we're thinking is each of those 3 pieces has to be raised to the second. Now, what happens when you do negative 4 raised to the second? Negative 4 times negative 4, which is 16. Now, please remember, if you do negative 4 raised to the second on your calculator without parentheses, it's probably going to tell you negative 16. But what do we know anytime we raise a negative power, or excuse me, a negative to an even power? It's going to become positive. So this is going to be 16. X to the what power? Negative 3 times 2 is negative 6. Y to the 5 times 2 is 10. My ending question. Am I done? No, why not? Yeah, can I leave a negative exponent? I can't leave a negative exponent. What do I do with a negative exponent? Put it in the denominator. So what's that mean that this answer is going to look like?
16 y to the 10th over x to the 6.
Right. The only thing that moves to the denominator is the x to the negative 6. So it moves to the denominator, becomes x to the positive 6. The 16 stays on top. The y to the 10th stays on top. So I'm going to have 16 y to the 10th over x to the positive 6. Because remember, when we move across that fraction bar, I've heard some teachers call it a magic line. When you move across that magic line, that changes my exponent power from negative to positive, or from positive to negative. Got it? Okay. Let's try C. 4a, b to the 6th, c to the 3rd, divided by a to the 5th, b, c to the 3rd. Thoughts on this problem? Kendra?
On the a half off, there's an invisible line.
Okay.
So once the line that we can subtract together with their match.
That makes the B on the bottom also.
Okay. So first of all, the a doesn't have an exponent, so think invisible 1, yes? And I also agree the b on bottom doesn't have an exponent, so think invisible 1s. Now, why are we putting those 1s on there? Because if you have an a on top and an a on bottom, what can you do with those powers? Subtract them, right? If you've got the same base, top and bottom, when you're dividing with the same base, the key is to subtract the powers. So a to the 1st divided by a to the 5th is going to become a to the, what's 1 minus 5? Negative 4. B to the 6th divided by b to the 1st becomes b to the 5th. Because 6 minus 1 is 5, right? What about C's? So we can think of, okay, two different options here. First of all, 3 minus 3 is 0. Now, I also heard the comment they cancel. If you have identical on top and bottom, can we also think canceling out? We can, because here's the deal. When we get to our next step, c to the 0, what is anything raised to the power of 0? 1. So this c to the 0 is going to become a 1 in the next step. Which means, will that essentially cancel the c out? It will. So whether you think 3 minus 3 is 0, now you have c to the 0, which becomes 1, or whether you thought, oh, c to the 3rd divided by c to the 3rd, they cancel. Both are appropriate thoughts. Now, what's the one thing that I left out here? That 4 out front. That 4 is just a number out front, right? So a coefficient. Is there a number on the bottom out front? No. So that 4 is just a 4. You can think 4 over 1 if you want. So I have 4 a to the negative b, a to the negative 4, b to the 5th, and c to the 0, or 1. Am I done? No. What's the key again I have to think about? Negative exponent. Okay, I can't leave a negative exponent, so how do I deal with that a to the negative 4th? Put it on the bottom as a to the positive 4th. What about everybody else? Okay, whole number of 4 stays on top. B to the 5th stays on top. What about c to the 0? It's 1, right? And 1 times 4 is just 4, so we don't have to worry about it. Over a to the 4th. Okay, guys. That's a lot of exponent rules crammed into 3 problems there. Are they coming back to you a little bit? Because if I want to argue, you guys have learned all those rules before. None of those rules are brand new to you. Now, maybe it feels like it today, especially being our first day of actual lesson back from break, but none of those rules are new, I promise. Yes? You can think about it as like 1 times 4, which is just the whole number 4. So, I mean, because it's a 1, when you multiply anything by 1, it just stays itself. So, I mean, you know, if it was any other number, I couldn't drop it out. But 1 times anything, it just kind of mixes in there. Okay. Yes?
So, like, if it, just for like me, say it was like a 3, would we just multiply that 3 times the 4? Okay, so, okay.
Yep. Yeah. If there was some other whole number here for whatever reason, then yes, it multiplies by 4. So if there had been a 3, 3 times 4 is 12. This is now 12 there instead.
Okay.
Yep. Okay. As I said, that's just a big old reminder of exponent rules. Okay. Example 2. Finding all real roots. Okay. And you will notice A, B, C, D, we're going to go through basically 4 different types of roots and talk about what they mean. I'll go through each of these. We'll talk about some calculator tricks. We'll talk about how to know how many answers there are and all of that. So, example 2A. What are the real cube roots of, and there's actually 3 different problems here, right? 8 thousandths, negative 1,000, and 127. 127. Now, yes, technically, can you think calculator to help you along here? You can. But there's also some other tricks I want to show you along the way. So, first part. What are the real cube roots of 0.008? So what am I asking myself when I talk about cube roots? What number times itself? How many times? Because it's cubed, we're talking 3 times, equals 0.008. Now, okay, the decimal. Forget the decimal for a moment. Just think 8. Can you come up with a cube root of 8?
Yeah.
That makes it a little easier, doesn't it? And I'll be honest. When I see a decimal, that's automatically what I do. Is I drop the decimal for a moment, and I just think about the number 8. 2 times 2 times 2 is 8, yes? So we can agree the cube root of 8 is 2. Now, notice, how many decimal place values are there? 3. Okay? Because it's a cube root, that's 1 for each part of the cube root. That's not said very well. How could I say that better? Yeah, for each time, I don't have a good way to say that. But the idea then is that if this is 0.008, that's 3 decimal places, yes? Then how many is going to be in our answer? And it's the idea that it's just going to be 1. So the idea that if it's 0.008, that's 3 decimal places, but since we're doing a cube root, You need 1 for each part of the cube. So 0.2 times 0.2 times 0.2. Now, some of you did that on your calculator. Did your calculator give you 0.2? It did. But it's also, I think it's helpful to know that, oh, 3 decimal places, so divide it by 3. That's going to give me 1 decimal place in my answer. So the cube root of 0.008 is 0.2. Yes.
Does that only happen with this? Like you have to, instead of like 0.002, it's 0.2. Or
It also happens like when we talk about like hundreds and thousands and stuff too. Okay. But I mean, yeah, my shortcut with decimals, oh, it's a cube root. So if that's 3 decimal places, and I divide, since we're doing a cube root, divide it by 3, that's going to give me 1 decimal place in my answer. Okay. Had this been, say, 6 decimal places, so 0.000008, 6 decimal places, well, if I divide that by 3 because it's a cube root, that means my answer is going to have 2 decimal places. That's kind of how my brain works. I mean, there's other shortcuts to think about and stuff too, but. Okay. Thoughts about negative 1,000? And kind of like I said, forget the decimal earlier. Forget the negative. Can you come up with a cube root for 1,000? What? Times itself again? 10? 10 times 10 is 100, times another 10 is 1,000. And this is, each 0 represents one of the roots, right? So kind of like decimals, 3 decimals, it's a cube. Well, 3 zeros, it's a cube. And so you can kind of drop off the zeros. What's the cube root of 1? That's going to be 1. Add a 0 here. Now, what about negative? In order to get negative 1,000, you would have to have negative 10, yes? So keep in mind, you can do a cube root of a negative. It'll just give you a negative answer. So cube root of negative 1,000 is negative 10. Okay. Again, your calculator can help you there. However, that's one to know the pieces. The cube root of a negative is a negative. 3 zeros means there's going to be 1 0 in my answer. And then cube root of 1 is 1. Those are some shortcuts to think about. Okay, 1/27. I'd like to argue you can do this one without a calculator too. I see a 27 in there. Yes? Can you come up with a cube root of 27? 3? Yep. 3 times 3 is 9, times 3 is 27. So the idea then, 3 in the denominator, what's the cube root of 1? Cube root of 1 is 1. So what's the cube root of 1 over 27? 1 over 3, right? In other words, think in terms of a separate numerator and denominator, is what I'm saying there. Okay. Questions here? Kind of see the cube roots, yes? And I'm not opposed to calculators helping you along, but I'm also trying to give you guys some tips and techniques when there aren't calculators. Okay. That one was cube roots. Notice this next one is fourth roots. Okay. What's it mean to do a fourth root? Yeah, what number times itself 4 times? Now, the first problem is 1. What can you multiply by itself 4 times and get 1? 1. So, what we are saying is that 1 times 1 times 1 times 1 is still 1. Are there any other options here? Negative 1 times negative 1 is positive 1. Times another negative 1 is negative 1. Times another negative 1 is positive 1. What happens when you multiply 4 negatives? It's also a positive. So not only is 1 to the 4th 1, but negative 1 to the 4th is 1. So it's asking for all of the real 4th roots. What are my answers? Negative 1 and positive 1, yes? Which you could write as plus or minus 1. So the real 4th roots of 1 are plus or minus 1. And Math Excel, well, it depends on the keyboard you get to bring up, right? There should be, if you can get the Math Excel toolbar, there's a plus or minus button there. Otherwise, they would let you probably do 1, negative 1. Okay. All the real 4th roots of negative 0.0001. So negative 1 10,000. Thoughts? I will say don't think too hard about this one. Fourth root of a negative 0.0001. Huh? No. So, if I removed the negative from this problem and said, what is the 4th root of 0.0001? I would agree with 0.1. What about a negative, though? What does 4 positives multiply to be? A positive. What do 4 negatives multiply to be? A positive. So 4 what multiply to be a negative? They don't. Can you take a square root of a negative number, guys? No. If you try and take a square root of a negative number, your calculator gives you some kind of error, right? Well, guess what? If you're trying to do the 4th root on a calculator of a negative number, it's going to give you whatever error your calculator uses. Okay? So, all of that to say, in this case, because of the negative, there are no real roots is my variation of no solution here.
Everybody in the class is arguing whether the answer is 2 or negative 2, and you know the answer is syntax error.
Okay. So, FYI, if you come across a square root, a 4th root, a 6th root, an 8th root, any type of even root of a negative number, what is your answer? No real roots. Now, that doesn't mean there's not imaginary roots, but we're not going there, so don't stress. Okay? We're staying in the real world.
We're going to get there.
Okay, guys. The 4th roots of 16 over 81. Now, like the last fraction I gave, what did I suggest? Think numerator, think denominator. Can you come up with the 4th root of 16? Two times 2 is 4. times 2 is 8, times 2 is 16. So we know that 16 is the same thing as 2 to the 4th. 81, what's it take 4 of? 3. 3 times 3 is 9, times 3 is 27, times 3 is 81. So 3 to the 4th. So I want all real 4th roots of 16 over 81. What are you going to give me as your answer? I think I heard it out there. Plus or minus 2/3. Now, in my teacher opinion, there is some good for being able to figure out the 4th root of 16 in your head by just, doing some mental math. Same thing with the 4th root of 81. Do I need to give a quick calculator lesson? Do you guys know how to find a 4th root on your calculator? Because your calculators can do this. And there's a part of me that doesn't want to show you this, but there's also part of me that knows I need to. So, any scientific calculator can do this. Now, I wouldn't mess with entering it as a fraction, but what I'm looking for, sorry, I've forgotten where it is on this calculator. Okay, so if you use the same calculator I do, above my x squared button is my square root button. Yes, this does any type of square root, but it only does square roots. Up here, above my exponent button, I have an x root button, which means I can do any root. On this particular calculator, I have to type in whatever root I'm doing. So if I want to do the 4th root, I will start by typing 4. Notice I have a 4 there. And then I will do 2nd and that button. So now notice it says 4x root. And so if I say of 81, notice that's giving me the 4th root of 81 to be 3. If you have a different scientific calculator, it's there somewhere. It's just a matter of figuring out where. On a graphing calculator, you probably have to go into the math menu. Okay? I'm going off the top of my head there. Yeah, if you go into the math menu on a graphing calculator, it's number 5. Okay? So, your calculator will do that. Okay, a calculator on a cell phone will do this if you get the expanded version. You just have to figure out where. Okay, and if you need help finding that, I can help you find that individually on your calculator. Okay, moving along. 5th roots. I'd like to finish C and D here. I got to move quicker. Okay, 5th roots. 5th roots means I want 5 of something, right? 5th roots of 0. What is any root of 0? 0. Because when you multiply 0, it's 0. So it doesn't matter what root we're talking about. In this case, the 5th root of 0 is 0. Okay? Next one is -1. We want all real 5th roots of -1. Well, forget the negative for a moment. What's any root of 1? 1. Can we do a 5th root of a negative number?
Yes.
Yes, because it's a 5th root. If you're doing odd roots, we can talk negatives. So what's the 5th root of -1? -1. Manipulate your calculator right, and it can tell you that if you want to check yourself. But again, I think these are good things to be able to know. Fifth root of 32. Well, you can go to the calculator, or you can use your brain a little bit. Notice, up in the last problem, 2 to the 4th was 16. So what's that make 2 to the 5th? 32. So what's the 5th root of 32? 2. Is there a plus or minus, or is it just 2? Just 2. Because with odd roots, it's just one number. Okay, and D. We finally get to the one that you guys know the best. Hold on. Well, don't hold on. Go ahead and start looking at D. I have to get my screen back here. The real square roots of 0.01. So square roots, this is what you've known for more years, right? When we talk square roots, we want multiplies by itself, right? Well, your calculator can tell you, but I'd rather you use your brain. Forget the decimals. What's the square root of 1? 1. Now notice, there's 2 decimal places in my problem. I'm doing a square root, right? A square root is like a 2. So if I divide 2 decimal places by 2, that means there's going to be how many decimal places in my answer? 1. So 0.1 square root. What do I need to consider? Plus or minus. When they want to ask you for all real roots, plus or minus. Square root of -1. Yes. I read your mind. Yep. I knew when you were asking that was probably the issue, the glare. You're welcome. Square root of -1. We can't do a square root of a negative, yes? Or correct? So, because of the negative, we're going to say no real roots. And, again, try and use your brains. Don't go for those calculators. Real roots of 36, 1/21. Square root of 36, 6. Square root of 121, 11. What do we have to say our answer is? Plus or minus 6/11. Now, I know I'm running out of time, but what I would like to mention here and right off to the side is kind of some summary rules. When we have odd roots, I'm going to write this off to the right here. I don't know if you guys have room, but I do. Okay, when I have odd roots, when I say odd roots, I'm talking like 3rd roots, 5th roots, 7th roots, 9th roots, right? All those technically exist, although we don't usually go above 5th roots. How many solutions are there every time we do odd roots? When we did 3rd roots, 5th roots, how many solutions were there? There's always one solution, yes? So my point is there's always going to be one real root. And what about the sign of that answer, the positive, negative sign? If my original problem was positive, my answer was positive. If my original problem was negative, my answer was negative. So the idea is that the sign of that answer matches the original base. So I'm going to comment here that the sign matches the base. And that is my summary rules about how odd roots work. Okay? I'm also going to do summary about even roots. If we had a positive base, how many solutions did you have? When we're talking even roots. So I'm talking square roots, 4th roots, 6th roots. When we did square roots and 4th roots, and it was a positive number, we had 2 answers, right? The positive answer and the negative answer. And so I'm going to comment here that a positive base is going to equal 2 real solutions. Those 2 real solutions being plus or minus. What about if it was a negative base? No real roots. Because if it's square root, fourth root, so on so forth, we can't do it. So a negative base equals no real roots. Okay, homework is out there and available. Not due till Thursday. I will pick up tomorrow where I left off in the notes. And I will leave that up there if you need it. Other than that, have a good day. Thanks for hanging with me.
I'm gonna take a picture real quick of the